is the portfolio rubric guidance for second grade standard 2OA A1. Add and subtract within 100 to solve one and two-step contextual problems with unknowns in all positions, involving situations of add to, take from, put together, take apart, and compare. Students will use objects, drawings, and equations with a symbol for the unknown number to represent the problem. When assessing for levels 0 through 4, the teacher is assessing the student's ability to add and subtract to solve contextual problems using 4 different second grade problem types. When adding, the sum should be more than 20. A subtraction sentence consists of 3 numbers, a minuend, a subtrahend, and the difference. The minuend is the first number in a subtraction sentence. We subtract the subtrahend from the minuend to get the difference. When subtracting, the minuend must be more than 20. So keep in mind when you are creating or using your contextual problems that your sum and your minuend must be more than 20. To assess, the teacher will present the student with one-step addition and subtraction contextual problems using numbers within 100, and again, the sum and the minuend must be more than 20 for each of the following problem types. 1, add to, start unknown. 2, take from, start unknown. 3, compare, smaller unknown. And 4, compare, bigger unknown. When assessing for levels 5 through 7, the teacher is assessing the student's ability to solve two-step addition and subtraction contextual problems using the 4 different second grade problem types. The student accurately solves two-step addition or subtraction contextual problems within 100. And again, the sum and the minuend must be more than 20 for each of the following problem types. 1, add to, start unknown. 2, take from, start unknown. 3, compare, smaller unknown. And 4, compare, bigger unknown. Remember, this must be a two-step addition or subtraction contextual problem. The teacher will read the contextual problem and the student will set up the equation on a sheet of paper. The student solves the problem using objects or drawings on the paper and creates and completes the equation. Students can use objects or drawings if they need them, but if the student can complete the equation without the objects or drawings, it is acceptable. The teacher does not set up the equation. Part of the assessment is the student being able to set up the equation to match the contextual problem. Under the suggested task portions for levels 0 through 4, you will find that there are examples of problem types that can be found in the appendix of our rubric, and you will see table 1. There are common addition and subtraction situations. This table provides teachers with examples of different problem types. The teachers must adjust the numbers in the example problem types to meet the standard. So you will need to adjust the problem types, the numbers in the problem types to be more than 20 for the sum and more than 20 for the minuend. The teacher can create their own contextual problems for each of the different problem types. For levels 5 through 7, The teacher will create their own two-step contextual problems for each of the problem types. Here is an example of the contextual problems for each problem type. The students will write the equation to solve the problems. So the first example, some bunnies were sitting on the grass and 10 more bunnies hopped there. Then 15 more bunnies hopped there. Now there are 62 bunnies in the grass. How many bunnies were on the grass at the beginning? So for example 1, there are 2 actions that happen. So it is a two-step problem, contextual problem. There is also the beginning unknown, the start unknown, and it is an add to problem. An example of the equation is listed there. For an example for take from start unknown, there is a contextual problem for number 2. Some apples were on the table. Charlie ate 10 apples, and I ate 10 apples. There are 37 apples left. How many apples were on the table at the beginning? So again, this is an example of 2 actions happening. So it is a two-step contextual problem, and the beginning is the unknown, and they have to subtract. For example 3, a comparison problem with the smaller unknown, they give an example. Julie has 20 more apples than Lucy. Margaret has 30 more apples than Julie. Margaret has 85 apples. How many apples does Lucy have? So you are given the larger numbers and the smaller is unknown. But again, the student has to follow 2 steps to get to the smaller unknown. The example number 4 is an example of a comparison contextual problem with the bigger unknown. Lucy has 20 fewer apples than Julie. Julie has 30 fewer apples than Margaret. Lucy has 35 apples. How many apples does Margaret have? So again, there are 2 steps that need to be taken for the student to reach the bigger unknown. The required method of evidence collections for all levels is a writing product. The student should be writing their equations on a piece of paper. You can also include the student's drawings on that writing product. For levels 5 through 7, if the student mastered level 4, then the teacher can move on to levels 5 through 7 task. If the student masters any levels 5 through 7, then the teacher only needs to upload evidence for the mastered levels. Teachers do not need to upload the evidence for every level. After you have assessed your students with 2OA A1, then it is time to score your student work. A rubric is provided for scoring your student work. The student work receives a level 0 when a student is presented with all 4 second grade one-step problem types and the student is unable to accurately solve any of the problems. If the student is able to accurately solve one of the one-step problem types, then the student work receives a level 1. If the student is able to accurately solve 2 of the one-step problem types, then the student work receives a level 2. If the student is able to accurately solve 3 of the one-step problem types, then the student work receives a level 3. And if the student is able to accurately solve all 4 of the one-step problem types, then the student work receives a level 4. If the student is successful at solving all 4 one-step problem types, then the teacher will assess levels 5 through 7. If the student is accurately able to solve 2 of the two-step problem types, then the student work receives a level 5. If the student is successful at level 5, then the teacher does not need to upload evidence of the student being successful at levels 0 through 4. If the student is able to accurately solve 3 of the two-step problem types, then the student work will receive a level 6. And if the student is able to accurately solve all 4 of the two-step problem types, then the student work receives a level 7.